So let's graph secant and cosecant function. The graphs of secant and cosecant functions are related to the graphs of the parent functions y equals secant of x and y equals cosecant of x. To graph y equals secant of b of x, we first need to graph the function. Well, what is secant related to? Secant is related to cosine. So we're going to first graph y equals a cosine of bx. Then you're going to use the asymptotes in several points to sketch a graph of the function. What you need to notice is that the value of b, if we remember, that represents a horizontal stretch or shrink. It just changes the period by a factor of 1 over b. So the period of y equals a secant of b of x is 2 pi over b. So it's the same as cosine. So looking at the characteristics of secant, the domain is going to be all real numbers except where we have our vertical asymptotes, and that's going to be at odd multiples of pi over 2. At these values, the graph has vertical asymptotes. And the interesting about these graphs is that the range is going to be less than or equal to -1, and y will be greater than or equal to 1. So in this case, the graphs have no amplitude. No amplitude. The period is 2 pi. So let's graph a parent function of secant functions. So what we want to do first is we're going to graph our cosine. So I'll graph cosine of x first. And remember, the period is 2 pi. So 3, 4. So 2 pi. Half of pi is pi over 2. Then we have 3 pi over 2. In this case, I'm going to go a little bit further. Okay, I'm going to graph 2 periods of these so you can see it a little better. So negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So cosine will start, cosine always starts at 1, right? So let's label that. So this will be 1, and this will be -1. So cosine starts at the 1. Then remember, pi over 2, we're at 0. At pi, we're at -1. 3 pi over 2, we're at 0. And at 2 pi, we're back here at the 1. Then let's graph a little bit more. Let's go backwards. So that's 2 periods of the cosine of cosine of x. Okay, so let's say this is our graph. Now, we have to identify which points secant has undefined points. So if we remember, secant of x is really 1 over cosine of x. So I have restrictions there. Cosine of x cannot equal 0, right? So what makes cosine of x equal 0? If you look here at the graph, you notice that 0 is where it hits the x-axis. So really, the points that are undefined are at our x-intercepts. So wherever you see those x-intercepts, you're going to draw the asymptotes. Okay? So at pi over 2, when cosine equals pi over 2, that equals 0, right? Cosine of pi over 2, that would equal 0, and that makes it undefined. It makes secant undefined. So just draw your vertical asymptotes here. Then you're going to sketch the other parts of the secant graph. So what happens is that at the maximum point, it's just going to go up. At the minimum point, it's going to go down. Okay, and then so the secant graph are the green graphs, the green parts here. Okay, so that is secant of x. then all we're going to do with these is we will change the period, we'll change what that a value is in the front. So go ahead and try this third example here on your own. So if you try this out, the period is still 2 pi, and then of course it's vertically stretched by 2. And so now instead the high points and the minimum points will be at +2 and -2. Again, you start by graphing cosine. Cosine normally starts at the high point, the amplitude, and then it goes down, down, up, up. And you can do the backwards part of it. And then you draw your asymptotes at the x-intercepts. Okay, so that's at pi/2, 3 pi/2, -pi/2, and -3 pi/2. And then at the maximum points, it points up. The minimum points, they open down. So let's go ahead and graph cosecant now. It's very, very similar. So when we're graphing these, you're going to first graph the function. Well, what is cosecant related to? Well, it's related to sine. So let's graph y equals a sine of bx. Sine of bx. Then you use the asymptotes in several points to sketch the function. The value of b, again, is a horizontal stretch or shrink by a factor of 1b. And so we know the period is 2 pi over b. So let's go ahead and sketch this first. So we're going to sketch the sine of x graph. So we know that the period is 2 pi. So 2 pi and then pi. Pi over 2, 3 pi over 2, and then we'll go ahead and go backwards as well. So -2 pi, -3 pi over 2, this is -pi and -pi over 2. So we're focusing on graphing sine, okay, sine, so 1 and -1. So sine starts at the midline, so it starts here, then it goes up, down, down, up, and then we'll go backwards the other direction as well. Okay, so those are two periods of y equals sine of x. So we do the same thing. Identify the points which cosecant has undefined points. Undefined points. So cosecant is 1 over sine of x. So we need to find when sine of x cannot equal 0. And so again, at those points, it's at the x-intercepts. So here, right? Sine of pi is 0, sine of 0 is 0, and so that makes the function undefined. So those are our vertical asymptotes. And then same as before, what you're going to do is that if they're maximum points, it's going to go up, point up, they're like parabolas pointing up, approaching those asymptotes, and then if it's minimums, then they're going to be opening down. Okay? So the domain of y equals cosine of x is all real numbers. All real numbers except multiples of pi. At these values, the graphs have vertical asymptotes. Okay, asymptotes. And the range is the same. Y is less than or equal to -1, and y is greater than or equal to 1. So the graphs have no amplitude. And the period is 2 pi. Okay? So then I want you to go ahead and try out graphing this example here, graph a cosecant function with one period, 1/2 cosecant of pi over x. So pause the video and try it out. So if you tried it out, this is what the graph should look like. The highest and the minimum is -1/2, the maximum is 1/2. And then the period changes to just a period of 2. So I start with 2, cut it in half again. And then the vertical asymptotes are wherever the sine graph would hit the x-axis. And then you finish up the graph. So I hope this helps you out. Thanks for watching.